Node.js has a built-in module called HTTP that allows developers to create all sorts of networking applications that can transfer data over the HTTP protocol, like for example, a TCP server that listens for incoming HTTP requests on a specific port and responds back to the client with HTTP responses. So in this lesson, you will learn how to implement a simple web API using Node's HTTP module that implements 3 routes based on the HTTP GET and POST methods. Let's start by creating a new directory named HTTP server, and within it, a file named app.js that will contain the code of our application. Within this file, let's now import the built-in HTTP module, which as a reminder, doesn't require any installation since it is a core package of the Node environment. Now, to create a new server instance, we can use the createServer method of the HTTP module that takes as single parameter a callback function called a request listener that will be invoked each time the server receives an incoming request. This request listener function takes 2 arguments, a request object representing the incoming request sent by the client to the server, and a response object representing the outgoing response sent by the server to the client. Now, in order for the request listener function to be able to actually receive requests and send responses, we must bind the server socket to a port using the listen method of the server object, which in our case will be the port 3000. So now, since for the moment the server is unable to respond back to the client as the body of the request listener function is not implemented yet, we can temporarily attach the following event listener to the server object that will generate a log each time a new client connects to it, which will testify that our application is already working. Once we've done that, we can save our file, open a new terminal window, and start the server by running the following command. From here, we can test our application by opening a second terminal window and sending a GET request to the server identified by its IP address and port number using the curl command. If we now look at the first terminal window the server was launched from, we can see that the application did generate a log upon request receival, which means that everything is working as expected. So now that you know how to implement a simple web server, let's move on to the next step where we'll be implementing a GET route. In web development, routing refers to the mechanism responsible for determining what should happen when an incoming request reaches the server on a specific route. A route being the combination of an HTTP method, also called a verb, such as get or post, and a URL, like for example get articles or post login. That being said, implementing a route essentially consists in first checking the method and the URN of an incoming request, and second, creating a function in charge of executing some logic and sending a response back to the client. So, to implement a getHello route that responds with an HTTP 200 containing the plain text string hello world, we can start with the following if statement within the request listener function that will verify that the request method is indeed get and that the request URL is /hello. Once we've done that, we can start building the response that, as a reminder, must contain a status line, a set of headers, and a message body. To set the status line of the response, we have to assign a code to the status code property of the response object. To indicate that the server successfully processed the request, we can set it to 200, which translates to OK. Now, to set a header, we can use the setHeader method of the response object that takes as argument a header name and a value. Since we're sending back a string of characters, we need to set the content type header of the response to the plaintext mem type. Now, to set the message body and at the same time send the response back to the client, we can use the write method of the response object that takes as argument either a string of characters or a buffer. Finally, we can use the end method of the response object to terminate the message, which will signal to the client that the message is complete, or in other words, that all data has been sent. Just note that it's also possible to directly call the end method with a string of characters or a buffer if there's only a single entity to be sent back by the server. We can now kill the server using Ctrl+C, restart it by running the node app command, and test this get route by running the following curl command using the v flag, which will force curl to be more verbose and give us additional information about the request and the response. As you can see here, the server successfully responded with an HTTP 200 OK containing the hello world string just as expected. That being said, let's now implement a post-login route that will simulate a login operation using an email and a password encoded in the JSON format. So similar to what we did for the previous GET route, we're going to start with an else-if statement that checks the HTTP method, the URN, and the content type header of the incoming request. Once we've done that, the next step consists in reading the message body of the request. Since the content of a message body can in certain cases be quite big, like for images or videos, it's usually broken down into several chunks of data that are sent one after the other. To gather these chunks, we must set up two separate event listeners, one that listens for a data event and that concatenates the received chunks to the previous one, and one that listens for an end event indicating the end of the data stream and that executes the business logic and sends a response back to the client. Once all the raw data has been received, in order to be able to use it, we need to parse it, which means converting it into a format the application can work with. In JavaScript, JSON strings can be converted into data objects using the built-in JSON parse method, from which we can unpack the values using the destructuring assignment syntax. Since we're implementing a login endpoint, we need to verify that the email and the password we parsed do match an existing user profile, which can be easily simulated using a simple if statement and two hard-coded values. Now the idea is that in case of a successful authentication, the body of the response should contain an object describing an access token, and the status of the response should be set to 200, which translates to OK. On the other hand, in case of an unsuccessful authentication, the body of the response should contain an object describing an error, and the status code of the response should be set to 401, which translates to unauthorized. Finally, we need to set the content type header of the response to application.json using the setHeader method to indicate that the response is in the JSON format, and serialize the message body of the response, which means transforming it into a string of characters using the JSON stringify function. Once we've done that, we can now kill the server using Ctrl-C and restart it with the node app command. To verify that the post route is working, we're first going to send a request containing an email password pair that matches the hard-coded values defined within the code, which as you can see causes the server to successfully respond with an HTTP 200 OK containing an access token. And second, we're going to send a request containing an invalid email password pair, which as expected causes the application to respond with an HTTP 401 unauthorized containing an error message. So now that we're done with this route, let's move on to the final step of this introduction, where we'll be implementing a fallback route. A fallback route is a special yet simple type of route whose only job is to respond with an HTTP 404 not found whenever an incoming request doesn't satisfy any of the criteria defined in the other routes of the application. In the context of our application, to implement a fallback route, all we need to do is add a final else statement, which will set the status code of the response to 404, the content type header to plain text, and finally send the response back to the client. We can now restart our application one last time and execute the following curl command that will send a GET request to an undefined endpoint named foobar, which successfully causes the application to respond with an HTTP 404 not found. So now that you know how to implement simple web APIs using Node's HTTP module, let's move on to the next lesson where I'll show you how to re-implement the same application in a much easier and much faster way using this time the Express framework.